There are machines built to last 5 years, and then there is Voyager 1, a spacecraft assembled with 1970s transistors, copper wiring, and a heartbeat powered by decaying plutonium. A machine that was never supposed to still be alive, and yet for nearly half a century it kept speaking, every single day, across a distance so incomprehensible it makes your brain short-circuit, sending its signal home, until one Tuesday in November 2023 when it didn't, and the transmission arrived right on schedule. But what NASA received was pure noise, gibberish, a stream of corrupted data repeating the same broken nonsense over and over, as if Voyager had forgotten how to speak. And engineers stared at their screens for hours, then days, because the spacecraft was still out there, still receiving commands, still technically alive, but it had gone dark in the most unsettling way possible. Not silent, not dead, just wrong, and what followed over the next 2 years would push NASA's most experienced engineers to the absolute edge of what's possible, using technology that hadn't been touched since the Reagan administration to keep humanity's greatest explorer from disappearing forever. Most people have no idea how insane Voyager 1's existence actually is. It was launched in September 1977 with a mission designed to last 5 years, tour Jupiter, tour Saturn, take pictures, transmit data, then quietly fade into irrelevance. And nobody at NASA wrote contingency protocols for what happens when the spacecraft is still working 49 years later, because nobody seriously believed it would be, and Voyager 1 has no modern software. No artificial intelligence, no self-repair systems. Its onboard memory is smaller than a single photo on your phone. It runs on 3 nuclear batteries that have been losing roughly 4 watts of power every single year since launch. And by the time 2026 rolled around, they were producing less than half the power they started with. And yet, despite all of that, Voyager 1 crossed into true interstellar space in 2012. Becoming the first human-made object in history to leave the solar system entirely and slip past the heliosphere into the cold radiation saturated void between the stars, where what it found rewrote textbooks, because interstellar space wasn't the empty, quiet nothing scientists expected. It was dense with plasma, buzzing with cosmic rays, structured with magnetic fluctuations no model had predicted, and Voyager was the only set of eyes humanity had out there. Which is exactly why when it suddenly started speaking in tongues, an entire room of scientists went cold. Here is what actually happened inside that spacecraft when everything fell apart. Voyager 1 uses 3 onboard computers, and one of them, called the Flight Data Subsystem, is responsible for one job and one job only: packaging all the science and engineering data from every instrument on board, formatting it, and sending it back to Earth. And on November 14, 2023, that system broke, not explosively, not obviously, it just started producing garbage. The computer kept running, kept doing something, but whatever it was doing no longer made any sense, and because every piece of data flowing back to Earth passed through that system first, everything was corrupted: science data, engineering data, health status, all of it indecipherable, and the spacecraft was screaming into the void with a broken voice, and no one on the ground could understand a word. And it took engineers 3 months of painstaking work before they narrowed down the source, until in March 2024 they sent Voyager a command that said, "Send us everything, every bit of memory, every register, all of it," and the response came back 23 hours later confirming what they feared. Approximately 3% of the computer's memory had been corrupted. A single chip had failed, not a major component, not a critical system. Just a chip storing barely 3% of the total code, but it was exactly the 3% that made everything else function. And here is the part that should make your stomach drop. There was absolutely no way to fix that chip, because it was 16 billion miles away, and no space shuttle, no robotic arm, no firmware patch was going to reach it. So engineers had to do something that had never been done before in the history of space exploration. They had to rewrite the spacecraft's own operating code, split it across multiple different memory locations to route around the dead chip, and then upload that rewritten code to a 47-year-old computer across 16 billion miles with a 46-hour round-trip communication delay and zero margin for error, because one wrong command, one corrupted upload, and Voyager 1 would be gone forever. Think about what that means in practice. Every command NASA sends to Voyager takes 22 to 23 hours just to arrive, then the team waits another 22 to 23 hours for a response. That's nearly 2 full days for a single exchange with no real-time feedback, no instant confirmation. Engineers write a command, send it into the void, and sit and wait for almost an entire day just to find out if Voyager heard them. And now imagine doing that while rewriting the software of a failing 47-year-old computer. Piece by piece, one carefully calculated command at a time, knowing the machine has almost no spare memory and almost no spare power, and that one miscalculation ends the mission permanently. This wasn't a software patch downloaded over Wi-Fi. This was neurosurgery performed through a 16 billion mile telephone with a 46-hour delay. The team worked for weeks testing each relocated segment of code individually, waiting for confirmation each time, and then on April 20th, 2024, after 5 full months of silence, a readable signal came back, real data, coherent and structured, from Voyager 1 for the first time since November, and the mission team at JPL erupted. People who had spent decades on this mission openly emotional in a conference room in Southern California, looking at a screen showing data that had traveled 16 billion miles to reach them. And humanity had pulled its greatest explorer back from the edge, or so everyone thought, because 6 months later the nightmare started again. October 18, 2024, routine day at the Deep Space Network. Engineers monitoring Voyager's signal noticed something wrong: the X-band transmitter. The primary radio system Voyager uses to talk with Earth had gone quiet, not reduced, not degraded, gone. The spacecraft had vanished from their screens again. And engineers spent hours scanning every frequency the Deep Space Network could detect, searching for any trace of it, until they found a faint signal barely detectable coming in on a completely different frequency, the S-band, a backup radio transmitter that Voyager 1 had not used to communicate with Earth since 1981, 43 years dormant. And suddenly it was the only thing keeping the mission alive. And what had happened was this: someone on the ground had sent a command to turn on a heater. The heater activated. And somehow the power draw from that single heater was enough to trip Voyager's automatic fault protection system, which responded by shutting down the primary transmitter to protect itself, and Voyager had put itself into emergency mode and fallen back on the most basic lowest power backup it had. A transmitter sitting untouched in its electronics for 4 decades waiting for exactly this kind of moment. And engineers were so shaken they spent weeks communicating only through that ancient S-band, trying to piece together exactly what had gone wrong, as if Voyager, battered and aging, had found its own way to stay alive using parts of itself nobody had needed in living memory. But the corrupted chip and the tripped transmitter were not the real crisis. The real crisis is power, and it has been building for decades. Because Voyager 1 runs entirely on nuclear batteries converting heat from decaying plutonium into electricity, and those batteries lose roughly 4 watts of output per year. And after 49 years in space, by April 2026, Voyager's total power output had dropped to less than half of what it produced at launch, with every heater, every thruster, every remaining instrument competing for that shrinking supply. And the math becomes brutal fast. In February 2025, NASA shut down the cosmic ray subsystem. In March 2025, they shut off the low-energy charged particles experiment on Voyager 2. Then on February 27, 2026, during a routine planned roll maneuver, Voyager 1's power levels dropped unexpectedly, approaching the threshold that would trigger an automatic emergency shutdown that begins killing components on its own, and there was no time to debate, so on. April 17, 2026, NASA sent a command to shut down the low-energy charged particles experiment on Voyager 1 itself, an instrument that had operated almost without interruption since 1977. Nearly 49 years of continuous science switched off in a 3-hour automated sequence. The command taking 23 hours just to reach the spacecraft, and after it went dark, Voyager 1 had just 2 science instruments left out of the 10 it launched with: the magnetometer and the plasma wave subsystem, and the power margins were still razor thin. NASA wasn't ready to give up, and while the world was absorbing the news of the shutdown, engineers at JPL were quietly preparing something they called the Big Bang. Not a metaphor, but an actual engineering procedure, the plan being to swap out an entire group of powered devices on the spacecraft simultaneously, turning off old power-hungry components and replacing their functions with lower power alternatives, all in one coordinated sequence of commands, the goal being to free up enough electricity to keep the spacecraft's heaters running, because in the -300°F cold of interstellar space, if those heaters fail, the fuel lines freeze and Voyager dies, not from lost power but from the cold. And if the Big Bang works, it could extend the mission by years, and there is even a chance it frees up enough power to turn the LECP back on, with testing planned on Voyager 2 first during May and June 2026, since it has slightly more power to spare and is closer to Earth. And if those tests go well, the same fix gets attempted on Voyager 1 no sooner than July. But nothing about this is guaranteed, because this is a procedure being performed on a 49-year-old spacecraft from 16 billion miles away using equipment designed before the personal computer existed. Open heart surgery on a patient already in critical condition, every step executed blind, command by command, day after agonizing day, with a margin for error that is essentially zero.